Hey, I'm just no chunk of coal, but I'm gonna be a diamond someday. Hello, we're on chapter 5, Structs and related data. Oh, oh my gosh. Okay, good time for me to interrupt this. This is a receipt. I have a receipt printer. Every time somebody subscribes, focus you. When you subscribe, it brings me immediate joy. I need the happy chemical. Chapter 5 is all about structs, and structs are really cool because I come from an object-oriented background, meaning that I hate myself and my stuff doesn't work good. I'm just kidding. I'm kidding. I know that my stuff doesn't work well. The first page on chapter 5 talks about how structs are pretty much exactly like tuples from way back in chapter 3, where they are collections of things that contain different types of values. And the real difference here is that we get to describe what particular value has what particular purpose. So they use a rectangle and they say width and height are the associated types, pieces of data, fields. Oh, I'm not zoomed in. Okay, now we're zoomed in. That's so much better. I also highlighted it so I wouldn't look stupid, but I didn't realize until just now that it's not actually a rectangle for their first example. It's a user and it has multiple different types and the rectangle comes later. But the point is that if you're referencing something inside this user thing way off in the middle of nowhere and you don't recall, or maybe you didn't write this code, but you know that there's this struct, you don't necessarily want to have to reference, the username by the 0th element of this thing like you'd have to do with a tuple, because that requires you to have some sort of a priori knowledge. But when it's a struct, you could just say like, oh, well, this user.username or user.email, and then it makes the code more readable for you and me, and that's nice. And the niceness doesn't just end there, because we have this wonderful syntax where if we're essentially creating an init function for this struct and we need to provide it some sort of values in order to initialize it, and those values commonly have the same name as they do in their parameters, well, then this whole email username, it's a thing that comes up so often that they just give you a shorthand so you can just define your parameters, and then as long as they have the same field names as the parameters, then it just makes it nice. And boy, oh boy, oh boy, it even goes further, where if you're defining a struct off of another struct, you can use like dot and then provide it the other struct you're basing its field values off of, and it just works, which is like really nice. But that's actually just the most basic struct in our default struct. We also have a tuple struct where we don't necessarily care about naming all of the fields. It's well understood that a color is RGB or a point is XYZ, and we can just define it this way. And this operates very similar to a named tuple, which I put a little red sticky note here because it reminded me of programming experience I had with Python. When it was initially talking about structs being like, these are just tuples with names and they allow you to have things reference them and write functions off of them, I was reminded of a concept about collections in Python by Raymond Hettinger. If you are not learning Rust and you have a Python background, holy crap, I love that guy's videos.
None of you've ever been to any of my talks before, what you're supposed to say right now. Ready? There you go. There must be a better way. Here, you guys ready?
But he introduced name tuples to me, which were basically structs. And I found that when I was writing programs, I didn't often fall into the object-oriented paradigm. And instead, I was just using named tuples all over the place, which is funny because it's like I fumbled my way into a struct-like layout of my program because of that talk, which is like surprisingly cool. And I don't know, maybe it's another thing to check out and I can put in the description. Anyway, the nice thing about these tuple structs is that when you define some sort of function that requires a tuple struct, it has to be that particular one, meaning that you're unlikely to make an oopsie poopsie and have one struct over here that has the same type signature as this other struct, and then pass one into the function when it doesn't belong there. So your compiler can do like a little bit of extra help to make sure that you do the right thing. And a unit struct is useful for certain things that I don't understand, like implementing a trait on some type, which we kind of talked about on the last episode where we were talking about drop and how that trait determines some sort of custom behavior for deallocating memory for a particular type. But I don't really know how it's used any other way, and I guess everything's just going to be discussed in chapter 10, so I mean, hold your thoughts until then, I guess. And then it goes into this weird thing where we talk about how a struct can actually contain references. So in this user struct, we have a reference to string for both username and email, and when we're actually invoking it, instantiating that struct, we have a string literal, which is then referenced inside that particular struct. And it basically just tells us, don't worry about that, it's happening in chapter 10. But it won't work because the lifetime of this is in question. So it tells me that there's probably something with like scopes, because we know that it would be invalid in some capacity. But it seems to me like there's no reason this shouldn't work, because, I mean, as long as we're using this user1 struct inside the same scope, I mean, it should... That should still exist, unless this is like a I don't know. It's beyond me. But I wrote a little sticky here, and I'm gonna have to get back to it because I don't exactly understand this lifetime thing, and I'm excited to rip off the sticky when I do understand it. Then we finally get to our rectangles, and it talks about, you know, these structs being used in some sort of example program and exactly how they're used. Kind of an interesting way to go about it, where it was like, here, we'll solve it with the knowledge we know, and then we'll talk about how a struct would make this slightly better and all this other stuff, which, don't get me wrong, is great. But if you're reading this chapter, I mean, all you really need to see is this page 90, from the code example to the adding useful functionality with derived traits. I mean, this is the meat and potatoes of this chapter. And then we get to the derived traits section, and we talk about, you know, how we can display something with like debug formatted curly braces inside of a print line macro, and how a struct doesn't by default have a display trait, and that's what it's going to be using underneath the hood. And that's all well and good, but when I was actually just fiddling around in Rust, I ran into this particular error all the time. And I read this note where it had like you can use a : to do the debug thing, or you can use a : octothorpe ? To get a new lined version of that pretty printed thing. All of this to say is, it seems kind of weird to me that we would need to do this. Like, we don't get the default display debug thing by itself. Like, it makes sense to me if we were just to create our own display for this struct, it would use that by default. But a sensible default seems to be including the debug version of that macro. If there's a reason why that's useful in a compiled binary, I don't see it. And I guess I'm just speaking from my experience with Python, but you can basically have some sort of thing implement its representation, and when you call print on it, it does whatever is in this function. And so, I mean, that's pretty much correlated with the display trait. So in my head, it's like, okay, well, why don't we just get this as a sensible default? What's even sillier about this whole thing is that it says Rust includes functionality to print debugging information, but we have to explicitly opt in to make that functionality available for our struct. I mean, what is the secret value of opting in that the book doesn't tell me here? I really want to know. Is there like some sort of security implication, or like, are they trying to say these are private things here, and that if it wasn't, you know, explicitly derived in this struct definition, it could potentially be seen in some other way? Why? Like, what does that buy me? I don't get it. But now we're talking about methods, and methods are different than functions because methods reference some particular struct, and functions can operate on any sort of things you provide as parameters. And it's useful because when we talk about methods, then we can use this self reference, and when we're talking about something, then we just can reference any of the fields associated with that struct using this self, so self.width or self.height. And when we're actually calling a method on some particular struct, we provide the instantiated struct, and then whatever that method is calling it, and that provides us that value, which is pretty cool. The thing that I loved and I wanted to make sure I kept it in was I wrote a sticky note as I read this where I was like, hey, will a method ever take self as a non-reference? And immediately below it says, having a method that takes ownership of the instance by using just self as the first parameter is rare. This technique is usually used when the method transforms self into something else and you want to prevent the caller from using the original instance after the transformation. Holy crap, that's great. Can you please tell me why this is the case in the same kind of way where it's like right here, and then I have the sticky note here because in our first example, when we're not using a method and we have this area as just a function that will take in a particular reference to that struct, we know, well, this thing is only useful as calculating the area of a rectangle. There's other area calculations that this function doesn't actually describe. And well, because specifically that, it makes sense for this to be a method. And then we don't have to have rectangle defined every single time, and our functions don't have to have rectangle dot whatever. It's just self, and that's nice, and I get it. But then I was like, well, what if I wanted to have a function that operated very similar to this example here, but could take different structs? And I actually wrote this out to say, like, let me write some code to figure that out. And then later it basically says in chapter 10, we're going to find out about that. And it's pretty much generic. So I'm going to have to go back to learn a little bit more about how I could implement that. And then there's this section here that talks about the arrow operator. And I remember learning about this and being a little bit more confused. And I actually really like the way that they just decided to solve it for you in Rust. Essentially, you need to know whether or not the thing you're, calling a method on is a reference or not. And in this, it's like, well, we can infer that based upon where it is and the ownership of it and all that. So, I mean, why don't we just do it that way and make it cleaner? And it's like, man, that's cool. And I think that's cool. So let's go program that all up. Okay, so for this chapter, we had a handful of things to test out and write code for, and I'm feeling a little bit more confident in how Rust is actually syntactically written, but it's still a little bit verbose for my taste. But let's start off with some of the things I thought were interesting. I guess I'll firstly say I'm still, if anybody does know why we don't get this derive debug by default, why they chose not to include that by default, I'd like to know. And beyond this, I learned syntactically that these braced struct definitions don't require a semicolon, but ones that are parenthetical, ones that use parentheses, do require that semicolon. And it seems a little bit weird to me because if I'm understanding correctly, things that end in a semicolon are necessarily statements. But things that do not end with a semicolon that would have been expressions essentially get turned into statements. Not necessarily you have one or the other, because the struct user would potentially return something, and I don't really know what a declaration would return. And I don't think it's a failure on the book's part, but maybe I'm just like too quick to put things into binaries. And in this case, it confused me because I was writing everything like, oh, this is a statement because it's declaring something, and it's like, well, no. And then later when we actually, create one of these particular objects, we have semicolons at the end because those are the actual statements. One other thing that I like to add to this, like, syntactical things that I figured out while programming this chapter is this comma at the end of the fields. If you see on the right here, I have this error that's thrown that says the base struct must always be the last field. So in some capacity, it's checking these commas at the end of these fields during the initialization or creating the instance of whatever that struct is. And it doesn't like it when I'm providing this comma in the struct update syntax. But for the struct directly above it, I can add that comma here just fine. And I think that's interesting. It's probably not going to come up a lot when I'm actually running my code or writing code. But I like to have these commas after every field because then I can move them around relatively quickly without having a lot of issues. So normally I'd be like, and I immediately get the sorted fields, which can potentially be useful. And it just goes to show that when I'm talking about like this particular user being instantiated, I have these 4 fields, and it doesn't matter what way I organize them in the way that I'd have to be with a tuple, but it made me wonder about like initialization functions, because I'm used to those. And one thing that I've seen in the initialization functions, I new functions, is that you oftentimes have multiple different variables inside the parameters, and it's often useful to know which one comes first and which one comes after, and that's often just the programmer's intuition, and that's why named parameters are nice. So I tried to create this user 4, which looks very similar to user 3, but in the case I didn't know at the time I was invoking this new function whether or not the first string was the email or the user, I could just write it this way, and then somebody looking back at the code would say, okay, this is corresponding to the email. And that's nice if you have something that's maybe not as intuitive as user and email in something like a user struct. But unfortunately, Rust doesn't allow named parameters. And so you just have to know by default, okay, well, this new struct must have the username and the email in this order. And if you don't know that, you just have to simply look at the definition for that function. I also have this deactivate here because, well, 2 things. One is I thought maybe I'd have to do some sort of this doesn't return anything, and that didn't have to happen. I just had to give it a mutable reference to self, which I thought was cool, and I didn't see or make note of that behavior inside of the methods. So I think the majority of the methods in this book, actually, I'm just going to go check. Let's see. Yeah, okay, so no methods inside of this chapter actually have nothing returned from them. So I guess that was an interesting thing to have just walked into, and something that I need to make note of for myself. The other thing that I thought was interesting about this deactivate function is I'm passing this mutable reference to self. I'm expecting a mutable reference to self inside of it. And that would inform me that, well, if I'm instantiating or initializing a particular struct of type user, and I'm intending to use this function, it therefore has to be mutable. I mean, it makes sense when I say it that way, but if I'm looking at somebody else's code and I see this ampersand mutable self, I know, okay, well, I'm going to be creating mutable instances of that user. And that's a little bit interesting because I guess what I would have expected from a like more memory safe, perhaps functional language, is you would return just a new instance of user, and then in this case I guess you'd do something like, there we go. Okay, so in this case I just made it so that deactivate returns a new user instance and I pull the rest of the values apart from active, and then when I create it I'm just shadowing that. And that makes sense to me, but I guess in my head when I was thinking about how I'd write Rust, I thought it'd look a lot more like what I just changed the code to than what I'm seeing here. I'm having a hard time explaining this, but what I guess I'm trying to say is when I see somebody else's code and it's using this reference to a mutable version of that struct, that I know that I have to instantiate it as mutable, and I have to accept that the borrow checker is doing all the work to ensure concurrency is easy. Yeah, I don't know if that was just like too much introspection and like, I don't know, too much weird hypothetical thinking, but it's just something that I maybe didn't think about before writing this code. The last thing that this chapter did that I wanted to do myself was implement this struct for the rectangle and all of its associated methods. So I have an initialization function that will just produce a rectangle if they have the same width and height, which is cool. The area and the can hold, And when I actually ran these down here, everything worked out just fine, as you can see over here. Anyway, that's all that this chapter actually does in regards to structs, and I feel like I have a pretty good knowledge about how they're actually used. But if you have recognized that I've said something wrong or inaccurate, or I don't have a full understanding, let me know in the comments below. And if I helped in some capacity, I'd also be interested in hearing about that. So thank you for watching, and I'll see you in the next chapter, enums and pattern matching. Bye.